Today we're starting lesson 2 on chloral bleaching. So what is the effect of sea surface temperature on the number of coral reef bleaching events? So bleaching means that the coral changes different color, okay? And they want to know, what does the temperature at the surface of the ocean have to do with that? Coral reef ecosystems are in trouble. About 20% of the world's coral reefs have already been lost, and that number may climb to 50% in the next 20 to 40 years. The main culprits are pollution, overfishing, and climate change. Warming ocean water is one of the main threats to coral reef ecosystems. So what are corals? Although they may look like plants or rocks at first glance, corals are animals. They're related to jellyfish. Each coral unit is what's called a polyp, and polyps secrete calcium-based skeleton-building coral reefs. So calcium is an element, and this element, calcium, is used in building the coral reefs. Corals and algae have a symbiotic, remember what that means, mutually beneficial relationship. The corals provide algae with a safe home and nutrients, while the algae provide the coral with the sugars produced during photosynthesis, which the corals use for energy. This symbiotic relationship is crucial for coral growth and reef formation. So why should we study the corals? The coral reefs are a critical marine habitat, accounting for 25% of marine biodiversity, even though they only occupy 0.015% of the ocean. So they occupy a really minuscule part of the ocean, but they supply 1/4 of the marine biodiversity. 500 million people depend on the coral reefs for food sources, coastal protection, building materials, and income from tourism. The net value of coral reef ecosystems has been estimated to be almost $30 billion per year. To say these ecosystems are invaluable is far from an overstatement. Despite covering only 2% of the ocean, they house 25% of its species. So coral bleaching is a natural process where corals lose their vibrant colors and turn white due to stress, and this is often caused by rising water temperatures. This happens when corals expel the tiny algae. These are called zooxanthellae, that live in their tissues and provide them with the nutrients and color. Remember, the algae is providing them with the sugar that they need, and the sugar is nutrients, and that's how they keep their color. So if they're expelling them, meaning getting rid of them, then they're not getting any nutrients. While the bleached corals are not dead exactly, they are stressed, and they're more vulnerable to disease and death if the stressful conditions persist. So when does the bleaching occur? Well, as we already said, that corals get stressed by heat, which makes them more likely to bleach. But it's hard to say exactly how much heat corals can handle because they are used to the temperatures that are in their own, local environment, their own area. Some corals can also adjust a little to changes in temperature. So to find out when corals are at risk, scientists watch for temperatures that are 1% or more above the usual high for that area. So this is called degree heating weeks. And they show how the hot water is and how long it stays hot over a 12-week period. So this is about a season, 3 months. If a coral reef gets 4 degrees heating weeks, bleaching is likely. If it gets 8 degrees heating weeks or more, then it's going to die. In general, the higher the DHW value, the more likely coral bleaching is, and more likely the coral is to die. These are just general rules. Some corals might survive even at high DHWs, while others might bleach or die with lower DHWs. Corals can sometimes recover if the heat stress goes away in time and they are supplied with nutrients. So summarize why rising water temperature is dangerous to coral. So what does the rising water temperature cause? Hopefully somebody said coral bleaching. So right in this first spot, we're going to write, why is this not writing? Oh, I see, I have to pick a color, but I did. Okay. Whoa, that's not what I want. Let's see. Background color is yellow. This is, there we go. Okay. Rising water temperatures cause coral bleaching. If exposed to the higher temperature for long periods of time. Okay, here we go. Why are some coral reefs experiencing bleaching events and not others? So the text said that above, actually, that these are just general rules. Some corals might survive even at high DHWs, while others might bleach or die at lower DHWs. So I think it's also going to depend. We've been talking about natural selection, right? So some corals might be more resilient and survive at higher temperatures, while others are more sensitive. So some might be more resilient and survive at higher temperatures, while others might be more sensitive. And then it says, what do you notice about the relationship between the DHW value and coral bleaching? We'll go right up to these 2 bullet points at the very top of the page. It says, if a coral reef gets 4 DHWs, bleaching is likely. If it gets 8 DHWs or more, corals may die. So that's a direct relationship. There is a direct relationship between DHWs and coral bleaching. The higher the number, the more damage or death. Whoa. Well, oh my goodness, it just moved it again. All right, let's see what's going on. Let me see if I can go back. It just exited my drawing. I will retype the last one. It is a direct relationship. The higher the DHWs, the more damage. And I'll put death. I don't remember what I put exactly before, but it's the same thing. All right, get that down and then we'll continue. So below here we have 3 world map from different years. We have 2002 to 2014. And the map shows how prone different areas are to coral bleaching. Now, you can't see it on your paper, but you can see that blue is a little bit prone, and there's a little bit of, blue all over the map. Yellow is moderate risk, right? And then we have high risk, very, very prone. So your high risk, very, very prone seems to be right here in the middle. I don't know if you can see that on yours or not. If you want to mark the colored areas on yours so that you can see it better, that's up to you. So this is the year 2002, right? And then, so what I would do is I would take colored pencils right now, because you're not going to be able to compare these. So you need to take the colored pencils and go over your circles so you know which ones are blue, which ones are red. So you need to do that. So take 2002, pause this, color your circles, and then when everybody's got them colored, then you're going to move on to the next map. Here are the next 2 maps. So you want to get all of those dots. And you can see very easily that there is more red. So get all the colored dots in on your paper, and then we'll continue. Okay, you need to have all of your dots colored, and what you're going to do now is you're going to answer your last 3 questions based on your data. I am not doing the last 3 with you. You need to try to answer them. Once you're done, you can turn in your assignment and work on anything that you owe. And I will see you tomorrow.